The second part of step 7 is going to be solving systems of inequalities. So we just finished up learning so much about systems of equations. Now we're going to look at how that less than or greater than symbol is going to factor into graphing a system of inequalities. So the first thing we're going to do is graph them just like we did in step 6. Nothing new, just graph this inequality. We begin at -4, we rise 2, run 1, and we repeat that over and over so we can get a nice line on our graph. Then we connect it with a line. As neatly as possible, because where we're going next in step 8, we're going to want to make sure we can graph these systems absolutely precisely as possible. All right, that is going to be a dashed line because it is greater than. And we need to shade now. So I'm going to grab my highlighter, shade above the line, or use a test point. Is 0 greater than -4? Yes, when I put 0, 0 in. So I shade above. Next, I'm going to graph the other inequality. I'm going to change colors. I'm going to make this one blue just to keep track of it. Begin at 3. The slope is -0.5, which is the same as -1/2. Down 1, right 2. Down 1, right 2. Or up 1, left 2. Grab my line and draw the line. Again, take time on this part. You want it to go right through all those points as neatly as possible. If you're doing this on paper, you want to make sure you use a ruler at all times. All right, that one is a solid line, and we shade below. Shade below the line, because 0 is less than 0 plus 3. So we're shading below the line. All right, once we have both of them on here, the solution is going to be the entire region that's kind of like a darkish blue or a purple color. This region over here. Here's my pink region, this is the white region, this is the blue region, and this is kind of the purple colored region. Every point in this region is a solution to the system. The system. It has to solve both the pink and the blue shading. Go ahead and pause your video and try the next example. All right, once you've graphed it, you will probably notice that there is no overlap section. So there is no point that solves both inequalities. So our answer for this problem would be no solution. If these symbols had been reversed and the first red inequality was shaded below and the blue was shaded above, we would have this overlapped region right in the middle. All right, Chelsea has final exams in calculus, physics, and history. She has up to 25 hours to study for the exams. She plans to study history for 2 hours. She needs to spend at least 7 hours studying for calculus, but over 14 would be way too much. She hopes to spend between 8 and 12 hours on physics. Write and graph a system of inequalities to represent the situation. You'll notice that on the graph I provided, it's only the first quadrant. The reason being, we're talking about how much time she's going to spend on calculus and how much time she's going to spend on physics. She can't have a negative amount of time. She can't spend -2 hours on calculus, for example. So I'm going to label my x-axis calculus, I'm going to label this one physics. All right. Again, you can use X and Y if you prefer. X would be the number of hours she spends on calculus, and Y would be the hours she spends on physics. In fact, we should put those units on here, talking about hours. I prefer to use C and P though. So she has up to 25 hours. So if she takes her calculus hours and her physics hours, she can be less than or equal to 25. That's what this part means right here. She has up to 25 hours to study for all 3 exams, but she plans to study history for 2 hours. So we're going to take away 2 of those hours. Calculus and physics cannot exceed 23 hours total then. When I count calculus and physics, it must be less than or equal to 23. I also know she needs to spend at least 7 hours for calculus, but 14 is too much. So that tells me that calculus has to be less than or equal to 14, but she needs to spend at least 7 hours. So 7. It has to be between 7 and 15 hours. And then our last little bit of information here that we have, she hopes to spend between 8 and 12 hours on physics. 8 less than or equal to P less than or equal to 12. So now we're just going to graph all 5 of these inequalities. C in between 7 and 14. Well, first of all, we need to come up with our increments that we're going to count by. Let's count by 2's. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And same on this side. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We know that the C value must be bigger than 7, but smaller than 14. So those are going to be some vertical lines. We're going to take it from 7, again, as neatly as you can. All the way up to 14. We can fix that one. Well, not exactly. Let's start over. I know it can be tricky to graph lines on your tablet. Just take your time with them. Make them as neat as you can. Okay, since it's between, we are going to shade in between. And again, take your time with this part because you need to keep things neat. All right, now let's take a look at these 2 inequalities right here. Bigger than 8, but less than 12. So if I put a line at P equals 8, which is kind of like a Y equals line, because P is our Y variable, and 12, it would be right here. And I know that I want that to be in between 8 and 12. So far, our solution set is this orange region right here in the center. But we have one more inequality to put on here. C plus P less than or equal to 23. Now, one of the easiest ways to graph this is with our intercepts. If she spends no time on calculus, she would spend 23 hours on physics, which would be, oops, wrong color. Right about here. kind of fallen off my graph. And then over here, if she spends no time on physics, she would spend 23 hours on calculus, which would be right about here. That's the easiest way to graph that next one because it has both variables. So we get our line on there. It is a solid line still. And I would shade below this line because 0, 0 is less than or equal to 23. Now, when I go to shade, I don't necessarily want to just shade all under the line because I know I'm not considering this region or this region. So I'm just going to shade under the line, but inside that orange area. Sometimes if you shade too much, the graph gets very confusing. So just this region would be my solution. If they ask for a possible combination, we could pick any point in here. All of these points would work. If they don't need it to be a whole hour, we could pick points that are in between as well. But our solution is everything in this green region. The last thing we're going to talk about is finding the vertices of a triangle formed by these three inequalities. If we go back to the problem we were just looking at, we made a green pentagon actually. It had 1, 2, 3, 4, 5 vertices. This last example is just formed by 3 lines, not 5, and it makes a triangle when you graph it. Sometimes, especially in step 8, we're going to need to know the vertices of the shaded region. And to do this, we're just going to use Desmos to graph. Split my screen. All right, we'll start with the first inequality. Y is greater than or equal to 2x minus 8. You get your line graphed. It's a solid line shaded above. Then we would shade the next line and graph it. And finally, we'd graph and shade our third line. And when we look at them all together on the same graph, you can see this triangular region. Now, the only way to find where these intersect is to, one, look at the graph. Sometimes you can tell exactly where they intersect. For instance, right here, this point where the red inequality and the green inequality intersect is 0, -8. This point right here is also very easy to see. That's -4, 7. This point is not so easy to see. And if we want the exact number, we would have to use our system of matrices to solve, to find out where they intersect. We would kind of stop treating them like an inequality and treat them like the equations again. So going back, the points that we definitely know are -4, 7, and we have this point down here, 0, -8. But the third point, 6.22 and 4.44. But notice, that is the intersection of the red and the blue inequality. The red and blue inequality. So our blue inequality is right here. And our red inequality, according to our Desmos graph, is the first one. So if I want those exact coordinates, not just a rounded decimal, I would need to take these. I'm going to subtract 2x, and I'm going to also add 1/4 x, so that I have my red line and my blue line. Now, They aren't officially in standard form, but we have x's, y's, constant. And that's all we need to put them into a system, into a matrix. So -2, 1, -8, 1/4, 1, 6. Let's go back to our matrix. Again, to get there, we go to desmos.com/matrix. And we want a new matrix. We want it to be 2 rows, 3 columns, -2, 1, -8, and on the bottom, 1/4, 1, 6. And again, when I reduce this to reduced row echelon form for matrix A, oh, I get the same numbers. I was afraid of that. Well, we could also solve it with substitution and elimination to avoid that, or we could convert these repeating decimals into a fraction, just like that. So we know that the other coordinates, the third coordinate, is going to be 56/9, comma, 40/9.